Okay, now we have question 3 using a calculator. So you can see this question is a tabular question. You're given a table or numerical, and you are given minutes and the degrees in temperature, okay? So we're not given a rate of change, we're actually given the degrees. Okay, now let's look at the facts. The temperature in degrees Celsius of an oven being heated has an increasing differentiable function. Okay, so that means it's continuous also, where T is measured in minutes. Gives every 4 minutes over 16-minute interval. Okay, part A. In the data, estimate the instantaneous rate at time t equals 10. So we're going to estimate the rate of change here. So to estimate rate of change then, we'll do the change in y over the change in x. So you can see then on the rubric here that when we're looking at 10, we would go 80 minus 73 over 4. So we get 7 over 4 degrees Celsius per minute. So notice for this, for your points, you show your work, the difference quotient, and then also you give your answer with units. If there's no units, then they would not give you that point. Now part B says, write an integral expression in terms of H, average temperature. Okay, so we know that's average value between t equals 0 and t equals 16. Okay, so we know then average value is the integral over the interval. So you can see here then, they have the interval is from 0 to 16 of the function h of t all over 16. So you can see that's worth 1 point right there. Now they want you to use a left Riemann sum. Okay, now we can see that the data points are increasing, right? So they're going something like this. Okay, and if we were to do left Riemann sum, and it's continuous, okay, so we would be making the left end of our rectangle the primary section there. So we would start here on the left then, okay, and draw my rectangle. Start on the left, draw the rectangle. Start on the left, draw the rectangle. So that means we're going to use the first values and not use the last value. So since it's going to be 4 intervals, since the intervals are 4, so it's 4 times 65, and then 4, 68, 4, 73, so forth. And so we end up dividing that all by 16, 71.5 degrees Celsius. So notice you get a point for showing the work on the Riemann sum and then getting the correct answer. Okay, moving along to part C. Now in part C, they want us to answer, is the approximation an underestimate or overestimate? Well, looking at the diagram here, it kind of labels it out nicely for you. You can see that since the function is increasing, my left Riemann sum is going to be an underestimate. Okay? So they would want you then to say the left Riemann sum is an underestimate because if you look at this integral of the graph of h is increasing. Okay, and that's basically all you need. So an answer with the correct reasoning. And last of all, are the data in the table consistent with, or do they contradict the claim that the temperature of the oven is increasing at an increasing rate? So that means that the rate of change is getting larger and larger. So let's look at the rate of change. So when we look at our table, we would look at the rate of change for the first 2 sets of data. So it would be, 3 over 4. And then the next set would be 73 minus 68 is 5 over 4, correct? 2 and 3, 5, yeah. And then we have 7 over 4. And then we have 10 over 4. So you can see that the rates of change are increasing at an increasing rate. So the type of explanation they're going to look for is, 1, you will be given a point if you consider the slopes of the 4 secant lines. In other words, the change in y over the change in x. So like what we just did, you consider those slopes. And then your explanation would be something like, since the slopes are increasing, the data is consistent to the claim. Okay, and then your conclusion consistent with the explanation. Now you could also use the mean value theorem to verify this, but it's not needed because the mean value theorem says that the slopes of the values, so we can see here if we find these are my input values, so since they are increasing respectively, then the derivatives must also be positive and increasing. And that is question number 3.